All right, today we have 4.5. We're going to be transforming all of our other trig functions, so tangent, cotangent, cosecant, and secant. I'm going to teach it a little bit of a different way than the author of the notes intended here with these start and end points, so y'all can scratch those out. Big thing we need to know is how to start these graphs, because if we know our starting point, then we can kind of go shape everything else from there. The big thing that we're going to need to know here with your functions is the new periods. That's going to be kind of a key thing here. So for the new periods for tangent and cotangent, you take the old normal period, pi, and you put it over b. And that's going to go for both of those. Your period for cosecant and secant is going to be tied into the periods for sine and cosine. So that's going to be 2 pi and then over your b value there. Okay, so coming up here, we'll start out with some of these transformations. Oh yeah, and then by the way too, just kind of knowing how the tangent graphs start. Usually tangent graph kind of starts and it goes through 0, so it starts at 0, 0. Cotangent typically will start with the vertical asymptote right there at 0. And I think the first point's at pi over 2 normally there. And then cosecant, remember that's tied into the sine graph. And sine starts at 0, 0. And then secant is tied into cosine. And the cosine starting point is 0, 1. So let's go ahead and start this first one here. We're going to graph tangent of 2 times x, and then we'll also find the asymptotes. So, with that being said, we'll figure out all the transformations. There's implied parentheses around that 2 right there. So the first thing I'm going to do is figure out the new change period here. So period is typically 2 pi, or I'm sorry, pi. And then we take that and we'll put it over the b value. The b value in this case is the thing multiplied times x, whether that is inside or outside of the parentheses. Like if you rewrite it like this, like kind of in its factor form, it's still 2 times x, our b is still 2. Okay, so we'll put pi and then over 2. Normally the scale I've been encouraging you guys to do here is making it to where it's like every 12 full ticks. Let's see if I counted that right. That should be good there. Every 12 ticks is 2 pi. And so with that being said, the pi over 2 right there, that's actually going to be 3 ticks wide. And that will help us figure out like how wide to make our tangent curves here. So pi over 2, what else we got? Pi, 3 pi over 2. So 3 tick marks should match up with pi over 2, which will help us get how wide that our period needs to be here. So with the tangent graph here, we'll start it at 0, 0. And then that means since the period's pi over 2, that means every pi over 2, you're going to have another 0. It's going to repeat and it's going to have that cycle. So it's every 3 ticks it'll cycle. So in between all of these points here is where you can place your vertical asymptotes. And unfortunately, they're going to be kind of halfway in between some of these tick marks here. So I'll get those as best as I can. And obviously you can go all the way to the edge of the graph if you want here. I think this should be sufficient right here for your vertical asymptotes. Now remember, tangent, those graphs typically will go up. So it'll kind of look like this. If you want to get a few more precise points, halfway between, I guess, 1 and 1/2 ticks and, I guess, 0, and so roughly like 0.75 of a tick here, you should go up, like 1 and down to -1. So depending on how you make your scale on your y-axis, that could be a little bit different, but kind of gets messy when you're trying to plot those there properly. So usually I just tell my kids, just get the asymptotes, get the zeros, and then get the shape of the graph. So don't worry too much about those additional points there. And then you can just get a couple of these curves. Usually they want you to do maybe like 2 periods worth. They didn't really say here, so you can graph as many of them as you want, or many or as few as you want. Really, you could get one curve if you wanted, but that would be that right there. And that's all you need to do. So the big thing here too that they're asking for is where's the location of the vertical asymptotes. So if you can figure out one and then tie in your period, your period is how often the asymptotes are going to happen. So for the vertical asymptotes, let's find one of them. And I guess I'm going to choose this one right here, halfway in between 0 and pi over 2. So if you think about it, halfway between 0 and pi over 2 is actually going to be pi over 4. So that's just right between those. And then it's happening every pi over 2, actually. Normally it happens every pi, but since the period's been changed here to pi over 2, it's actually every pi over 2 in like that. And that will be your location of your vertical asymptotes. So, and don't try and simplify that down. N can be any number, so it could change, things, I guess. So just like that, it should be good enough. So I think we got everything. Locate the vertical asymptote, sketch graph, we're good to go. So now we got a couple of more tangent graphs with some more transformations coming up. So let's try these right here. Locate the vertical asymptotes and then sketch graph of each function. Okay, so this one here, be kind of careful. Your b value is not 2. It's actually going to be a b value of 1/2. It's actually, if you want to rewrite it, you could rewrite it like this here. Tangent and then 1/2 of x, kind of like that. I guess we got the negative out front. So that's going to do a couple things. The 1/2 is going to change the period, and then the negative actually will do a reflection across the x-axis like that. Okay, so the period normally is pi over your b value, so it's going to be pi divided by 1/2. What I'm going to do is go off to the side and I'm going to do keep change flip. Instead of divide by 1/2, I'm going to multiply by the reciprocal, which means the period is actually going to be 2 pi in this case here. So it's actually kind of like a horizontal stretch is happening here. So I'm going to go ahead and start sketching that out. 3 ticks is pi over 2. So pi over 2, pi, 3 pi over 2, and then 2 pi finally. Now I guess I'll label the y-axis like this right here. You can honestly label the y-axis with any scale you want. This is typically what I'll do. Okay, so tangent once again should start at 0, 0. That could change if we have like a phase shift or some type of vertical, or I guess I should say horizontal shift. But since the period is 2 pi this time, that means the next order pair, the next 0 is actually going to be at 2 pi. It's going to be significantly stretched out. And then just if you know the general shape of this here, we should know that halfway in between your 2 points should be a vertical asymptote. Okay, so that should be 6 away, I guess, from the x-intercept. And if I go 6 more over here to the left, you can get another vertical asymptote. Should be a little bit off right here. And I'm actually going to go ahead and grab one more vertical asymptote. 1, 2, 3, 4, 5, 6. Somewhere right there if I count it correctly. Okay, and then halfway between those, you can go up one. These actually plot out pretty nice. And then halfway to the other direction, down one. But actually, hang on. There's actually a reflection. So let's change that there. Let's make those go down. Halfway in between. Luckily, I caught that pretty quick. So we'll kind of flatten out there a little bit, less steep there in the middle, and then go down at the end. So honestly, it kind of looks in a way like a cotangent graph, because cotangent graphs typically decrease. So yeah, a little bit less steep there in the middle, and then down. And that's how you're going to approach that. You can't really fit, with our scale that we have, we can't really fit as many periods worth right there. So location of vertical asymptotes, looks like it's the first one's at pi. So yeah, let's label that vertical asymptotes. It's going to be the first one's at pi, And then the period's now 2 pi, so I'm actually going to put 2 pi and then times n. N, remember, is just any integer right there. So that'll be that. Okay, so next one here is going to have a horizontal shift, or sometimes phase shift when you talk about sine and cosine. So let's see what happens here on this one. This one right here. This is actually going to be right 3 pi over 2, which I think that is usually 9 ticks. Let me relabel my x-axis just to double check. You got pi over 2, pi, 3. This is 3 pi over 2. Yep, so that's at the 9th tick. And then at the 12th, 2 pi. Okay. The b value being 1 means when you do your period, it's actually not going to change. Normally it's pi and then over your b value, but our b value happens to be 1, so your period stays as 1. Or 1 pi, I guess I should say. And then since tangent usually starts at 0, what we're going to do with this here is it's going to move right 3 pi over 2. So that'll be the first 0 right there. Now the period being pi right there, pi should be 6 wide right here. So that means 6 units from that starting point, you'll put another point, I guess as a 0. And I actually can go 3 to the left here and put a point there at pi over 2. And halfway between those, you get to put your vertical asymptotes. And then I guess we'll have one kind of over here. There we go. So that'll be 3 periods worth right there. And then halfway in between pi over 2 and pi should be at 1. That's kind of like at a tick and a half. And should look something kind of like that right there. So yeah, once you do a couple of them, it's really not too bad. Comes out pretty good. So that's about it right there. Guess we'll quickly go ahead and grab the vertical asymptotes. The vertical asymptotes, you can choose the one that starts at 0. I guess I'm going to choose the one that starts at 0. So first one starts at 0, and then it's every pi. It's tied to the period. So every pi, and then I guess n there on that one. So that should be it. You can simplify that, by the way, if you want to write it as x equals pi n. That would be sufficient right there. All right, so that's a couple of tangent graphs. Let's do one cotangent graph right here. You got the number out in front here. Might need to mess around here, I guess, with the scale, because look here, your b value winds up being 1/3, kind of like one of the previous examples with the tangent example. So what we'll do is we'll say, okay, the period is going to be pi, and then over the 1/3. When you keep change and flip, that'll be pi and then times 3, so 3 pi wide. Okay. Now that's getting pretty wide. If we do like every 12 ticks is 2 pi, means every 6 ticks is 1 pi. So 18 ticks for 3 pi. That's going to start getting kind of wide. And this is where I would start considering to maybe change the scale a little bit, at least on the x-axis here. So I don't know. I guess I'm going to make I don't know. I guess I'll do every 4 ticks is pi here. So I'm modifying the normal scale of this here. So we could go pi, 2 pi, 3 pi. See if I can grab 4 pi. 1, 2, 4. 4 pi. If you want to go back this other way here, this over here would be negative pi. So there's a couple of spots right there. We'll keep the y-axis scale the same. So this thing is actually really stretched out horizontally quite a bit. It's not going to quite look like that since we already kind of stretched out our x-axis scale there. But now that we kind of have that going, in our scale that we have here, 3 pi, I guess is that, it's actually, and it happens to be 12 wide just based off of the scale that I got right here. So that should be how that goes. Now, cotangent, you got to remember, it doesn't start with a point at 0, 0. It actually starts with an asymptote at 0, 0. And the only thing that might change that is if you have something that's moving it left or right. So it'll be the first location of one of those, and then the second location of one of those should be right there. And then halfway between should be roughly 1 and 1/2 pi. That is where your x-intercept point should be right there, right in between. And then I guess in between those points right there, I think it'd be, that's 6 total ticks. So maybe here at 3, you go up and down 1. And remember the cotangent curves, these will go downward. So it gets really wide looking there like that. And if we graphed it on my normal scale, it'd be almost too wide to even fit on this type of grid right here. I guess if you wanted to try and fit in like another curve here, I guess it's, if you count it, it's 6 points or 6 ticks wide from a point to an asymptote. So I'll count out 6 more. 1, 2, 3, 4, 5, 6. Yeah, like way over here. So it'll kind of look like that. So you can't really grab a whole lot more there, but that would be your cotangent graph right there. So usually not too bad there. The worksheet will have some pretty good examples for the day. So yes, still want the location of vertical asymptotes, so let's go ahead and write those in. Now the homework will ask for a couple extra things. They might ask for like the new x-intercepts, or maybe the domains and ranges and stuff. So you'll have to kind of look at your graph to interpret those there, but check the key if you're getting stuck. So first vertical asymptote is at 0, and then it's happening every 3 pi. So I'll put plus 3 pi and then n, which comes out to 3 pi n. And that'll be it. I believe that is going to be it there for tangent and cotangent. So we will finish up here with a couple of examples with as cosecant and secant. These get a little advanced, so just kind of watch out. And also, I'm going to change them just slightly here, just to kind of beef them up a little bit. So if you want to scratch out the original problem, essentially this first one here, I just added in a negative out in front, just to kind of talk about how that affects the shape. And then over here, we'll get to it here in a second, but I drastically changed that one where I kind of got, a different vertical stretch, a period change, a phase shift, a vertical translation, so a lot more things going on. So the big thing with graphing cosecant and secant that I tried to emphasize when we learn the parent functions is we're actually going to use the graph of sine to help us out here with this. So I'm going to go ahead and rewrite this with sine. We're going to graph negative and then sine and then all of the same stuff, x, pi over 2, and then plus 1, kind of like that. And I'm going to do the little box method where I get like kind of the box, and then, sine usually starts and ends there, and then it kind of goes up and down. And we'll get those points inside of our box, and then we'll go and figure out our new asymptotes and all of that stuff afterwards there. But we need to kind of get the points located, and then we can go and convert it into a secant type of graph. So with this one here, there's kind of a lot of things going on. The amplitude number that kind of matches with this is 1. I know there's a negative out in front. That just means it's going to start going down first instead of up. So we'll address that in just a second, but it's still going to go up and down 1 unit. Next, the B number is implied to be 1, which means the new period is actually going to stay as 2 pi over your B, which stays as 2 pi. So nothing's going on with the period. We'll mess with the period on the next one in just a moment. The new midline is actually going to move up 1. I can't remember on the homework. They might ask for the midline or they might ask for the vertical translation. Those are the same thing, up 1. And then we have one more thing. We have a phase shift. Usually use PS to abbreviate that. It could also be called a horizontal translation, but that should go to the left and then pi over 2. So now we have all of that. Now we're going to piece it all together. We're going to get our box sketched. And I'm going to use the normal scale, pi over 2 every 2 tick, or every 3 ticks. 3 pi over 2, and then finally 2 pi. I'm actually, since we're going to go left here, I'm actually going to label this as a negative pi over 2, because we're going to actually have to go left pi over 2. And then I'm going to label this as 1, 2, and then 3 every 2 ticks. It doesn't really matter, you know, how many of those you do. 1 or 2 ticks should be good enough there. So now let's go and graph everything here. So I'm going to try and sketch the little box here. Now, first of all, I like to usually go get the midline first. The midline is going to be at positive 1. So the graph is going to oscillate around. That's going to go up and down, whatever the amplitude number is, from your midline. So you're actually going to go up and down 1. And then down 1 right there would be kind of along the x-axis there. Okay, since it's moving left pi over 2, the left of your box is going to be over there at negative pi over 2. And then the period is 2 pi, which is 12 wide. So from the left edge of your box right here, you should need to go 12 units from there to make sure the box that we're going to fit everything in is the appropriate width. I'm going to count that up here. I think that would end over here at 3 pi over 2. So you can kind of see it here. I'll highlight for a second and then I'll erase the highlighting. But that is our box that we have that we want to fit our sine graph. Now normally sine, when you kind of have this drawn out here, sine usually starts at 0. But our midline moved up, so it's kind of like starting at 1. But it started in the middle of your box, essentially. And then it needs to end at the middle of your box. Halfway in between those, it should be at its middle point. And then here's where you got to watch out with this. Because of the negative, it needs to go, I guess, down first. So what I mean by that is instead of going up like a typical sine graph, it's going to go down and then up, because of the reflection piece. So if you go and kind of sketch that, I usually don't encourage you to actually sketch the sine curve there, but that's it. So what we're going to now do with that sine curve is transfer this into the cosecant graph, and I'll do it in red so you can kind of see the difference. If you want, you can go and highlight right there. You could even delete the line if you want, if it's kind of messy there for you. I usually don't draw the line. So what I'm going to do now is these points that would have been x-intercepts, these points right here, I guess where they cross with the midline, those are going to be the vertical asymptotes. Just like that. And then these max and min points are going to be the locations of the actual points on your cosecant curves. Just like that. Usually there's not any other decent points, so that should be good enough right there. So what I have here in red is the final answer here. This is the cosecant. It's got the left pi over 2. It's got the plus 1. It's got the same period, and then it's got the negative out in front. Now, once you start to kind of get a pattern going here, you can actually extend it here. Like you could go get another low point 3 ticks away from this point right here. Go 1, 2, 3, and then down 1, and there would be a min point. And then go over to the right, 1, 2, 3, and then up 1, and that should be another asymptote. And you can keep doing that all the way to the edge of the graph if you want. And get another period worth. And that should be it right there. Okay. I guess let's go ahead and stay consistent here. Let's go ahead and get the vertical asymptotes. They're at kind of different spots, so you just really got to look at each individual graph to get them. But I guess the first vertical asymptote that I see is at pi over 2. It's not adding the period like tangent always is. The distance, I guess, between the asymptotes there is 6 wide. That is pi. So it's actually plus pi in. It's usually half of your period. period's 2 pi, half of 2 pi is 1 pi. That should consistently work there on those. So usually it's plus and then half of the period and then n right there. So that one gets a little tricky. Y'all will have to practice. There's plenty of practice of the cosecant and secant graphs on today's homework, so it should be good there. So let's roll with this last one here. This last one I threw a little bit of everything. If you can get this, you're probably going to be prepared for any type of problem that I could throw at you on a test or quiz. So change the original problem there to 2 secant and then 3x and then minus 1. The first thing I want to talk about here is getting this to where it's in its factored form. To do that, we need to undistribute the 3. You can kind of like put a separate bracket there if you want. You don't have to. But you want to undistribute the 3. And if we're going to go and divide pi by 3, I'm going to write it like this. I'm going to write pi divided by 3 is the same thing as pi times 1/3. And then that comes out to pi over 3. That is what should go in the parentheses there. Right? Pi over 3. And then you'll have the plus 2. Okay, now off to the side here, I'm going to go graph something else to help myself. Secant is tied into cosine. So we'll go and graph this cosine graph that looks very familiar to it, and then we'll do like a reciprocal part afterwards. Okay, so couple things going on here. You got a new amplitude. The amplitude is not going to be 1. It's going to go up and down 2 from wherever your midline is. Okay. The period, normally your formula is 2 pi over b. So it's going to be 2 pi over 3. Now don't forget here, I use this to help myself. 2 pi is usually 12 wide. Sorry for the little extra mark there. So if you divide that by 3, 12 ticks divided by 3 should be 4. So that means your period should be 4 wide. Based off of our normal scale that we use. If you change the x-axis scale, it could change how wide you make this here. But my normal scale of pi over 2, pi, 3 pi over 2, and 2 pi. It's going to go right there. And so 4 wide according to that. And I'm going to make each of these here 1, 2, 3, and then 4. Okay. So let's see now. Yeah, we're going to get a little cramped here. I probably should have made the midline something else, but that's okay. We'll make it work here. All right. What else we got here? We got right. And you got to look at the factored form. So it's not right pi. It's actually right pi over 3. Now, I brought this up once here. 1 tick is typically pi over 6, meaning 2 tick marks is 2 pi over 6, which actually comes out to pi over 3. So right pi over 3 is actually 2 to the right. So that'll get a little bit weird. I'm not usually going to label that every time, but maybe for this one in the notes so we remember which one's which. That'll kind of help us, I guess. And then I guess you have the midline that moved up to. Fortunately, that it's not the greatest, but that's okay. We got an amplitude that's going to mess us up here. It's going to be a little tight up there at the top, but that's all right. We'll make it work. All right, so I think that's everything here. So let's go ahead and start this out. So the left side of our box, the starting point is at right pi over 2. Or sorry, pi over 3. So I'm going to do the left side of the box there. The right side of the box is going to be, well, it should be 4 wide total. So I'm going to go 1, 2, 3, 4. That'll be the right side of your box there. Okay. The midline moved up 2. So that would be located right there. You can extend it as long as you want there. And then the amplitude from there is going to go up 2 and down 2 from there. So inside of that little box is where I should fit my entire cosine curve. Remember, cosine usually will look kind of like this here. It'll start at its high point, end at its high point, halfway between those you should have a point, and halfway between those it should cross with your midline. So I'm going to go ahead and sketch all that there. Highest point again at the top right of the box, halfway between, it's going to be real skinny here. We'll put its lowest point, and then halfway between those, you're going to put these additional points, and it'll just get real tight. So this would be one of your cosine curves, like this. Okay. So with that being said, I'm going to delete here the cosine graph itself. What I'm going to do now is just like before, you take these points right here where it crosses the midline, and those, when you reciprocal those points and then do your transformations, these red lines here that I'm drawing are going to be your new vertical asymptotes, which are actually happening every 2 units. This is why I don't have all, now I got like so many dotted lines. Some people might go back and erase them. You could do that if you want. I don't really want to lose my box location there, so I'm just going to try and focus in on the red part. There's red parts right there. Those are going to be your vertical asymptotes. These extra points right here will be the mins and max points on these here. So really kind of narrow looking. They're almost like parabola shapes right there. This is kind of what I was talking about earlier. Didn't really leave myself a whole lot of room up there to fit those. That's technically kind of what it looks like. If you follow that pattern right there, it's kind of like over 1 and up and down 4. Over 1 and up and down 4 right there. So there's another point for an asymptote. And then here's another min point right there. Should have an asymptote here as well. And just continue your pattern. I think this one would start up kind of like that. It's a real kind of skinny looking graph there. Now I like this one here. Now we can kind of talk about the location of the vertical asymptotes. I guess you could call the first one, you could call it at pi over 2, you could call it at pi over 6. There's a lot of different starts where you could do, but any of the red lines right there. I guess I'll start with the first one I see, which is pi over 6. So I guess there's, sometimes you could have multiple answers here on these. If it's 2 ticks wide, that should be pi over 3. That's 2 ticks wide and wide right there. And then I guess you could put in. Also, I kind of mentioned earlier, whatever your period is, if you do half of it, half of 2/3 is 1/3. That's what you put as far as like plus the pi in thing. So plus a 1/3 pi in, and that should be the location of the vertical asymptotes there. So that one's pretty advanced right there. That's as bad as they could get there. But if you can get that right there, there's literally nothing else we can throw at you that you wouldn't be able to handle there. So anyways, that is it for the lesson, I think. Yep, that is it for the lesson there.